Now let's look at measuring temperature. When a substance is heated, some of the physical properties can change. So these thermometric properties include things such as the volume or the density of a substance. So you should remember that when we heat a substance, we've said there is going to be some physical changes that we see. So these include the volume. For example, when you heat a liquid, the volume increases. So we can use this property to measure temperature. Now we call this property a thermometric property. Or we can use the change of density to measure temperature. Another example is the electrical resistance of a substance. Electrical resistance of a substance is a thermometric property of that substance, because when it is heated, this changes. So if these properties change in a well-defined way, by measuring the property, you can determine the temperature. So let's see how we can use the tool to determine temperature of a substance. So let's look at how we make a temperature. How we make a thermometer. In order to build a thermometer based on one of these properties, you need to start by measuring the property at some well-defined fixed point. A fixed point is a temperature at which some easily identifiable changes occur, such as melting of an ice and the boiling of pure water. So we can say these are fixed point. Melting of an ice, it melts at 0 degrees Celsius. So 0 degrees Celsius is a fixed point, and the boiling of pure water, which boils at 100 degrees Celsius, which is, we can also say this one is the fixed point, the upper fixed point. So here we are making a thermometer. So when we put this thermometer, which is not yet calibrated, at 0, it melts, and at 0 degrees, or at a melting ice, the liquid is going to contract to this point, and when it is being boiled, it expands at this point. So let's see how we therefore use this thing. So this fixed point allow you to know the temperature without having to measure it directly. So usually two fixed points are used, which is the lower fixed point, the melting temperature of an ice, the upper fixed point, which is the boiling temperature of a pure water. Once a property such as an electrical resistance or the volume of liquid has been measured at these two fixed points, the values of that property at other temperature can be worked out. For example, when making a liquid in pulp thermometer, the distance between the two fixed points is divided into 100 equal degrees. The thermometer now has a linear scale. In other words, it has been calibrated gradually. So let's look at this one. So here we have a lower fixed point. So let's say this is the lower fixed point, which is 0 degrees Celsius. So that is where the ice melts. Then we have the higher fixed point where pure water boils. We know that we mark that one as 100 degrees. So we measure the distance from 0 degrees to 100 degrees to that point. And then we are going to divide it into 100. So I have made an example here. If the distance is 15 centimeters, suppose this distance is 15 centimeters. Now, so what does that mean? 1 degrees therefore is equals to 150 millimeter divided by 100 degrees Celsius. So it means 1 degrees is going to be 1.5 millimeter distance here, 1 degrees. So, and therefore you measure 1.5 millimeter and then you mark, which is from 0. So you divide that into 100 equal divisions. So in that case, you have you have calibrated your thermometer. So meaning if 1 degrees is equals to 1.5 millimeter, then 10 degrees is equals to 15 millimeter, etc. All right. So also even in thermocouples, we have resistance. So the upper fixed point, we mark it, and then we have the lower fixed point, we mark it. So we are going to divide this distance of resistance. So this one, we're going to divide it by 100, as I have shown it here. 1 degrees Celsius is equals to R2 minus R1 divided by 100. So suppose this was a resistance, I will just use any number. Let me say this one is 2. Suppose this one is 2 ohms, and then this one is uh, let's say 12 ohms. So the difference here is what? Is 10 ohms. So let me say this one is 10 ohms, so which is the resistance. So it means you are going to divide that 10 by 100 to get the difference, to get the size of 1 degree Celsius. So we are going to talk about how a thermocouple is made so that you understand the issue of resistance one. So I want us to look at these terms: sensitivity, range, and linearity. The above description has been a big assumption about the way in which the property changes with temperature, that it does so at a steady rate. Properties that change in this way are said to be linear. So when they change at same rate or a steady rate, we say they are linear. And linearity is a very useful property of for something to have, as it makes it easy to work out the relationship between that thing and the temperature. So in other words, when we say it has to be linear, we mean there has to be a same change of the thermometric property for a given temperature change. Same change of the thermometric property for a given temperature change. Ungakhanzi ukuthi when it changes from 10 to 20 degrees, the thermometric property changes great. And then when it changes from 40 to 50, it changes a small, the change is small. Now it has to be the same because we are using 10 degrees Celsius on both examples. So the change has to be the same, the change in the thermometric property of that material. Other important properties which when designing a device such as thermometer include a sensitivity. So if you are measuring changes significantly, when the temperature changes, it makes it easier to detect a small change in temperature. Your thermometer is more sensitive. So its sensitivity, it is the degree the degree of change of the thermometric property for a given change in temperature. So if the change in the thermometric property is great, or if the change in the thermometric is great for a small change in temperature, it means that thermometer is sensitive. Let me repeat myself. If the change of the thermometric property is great for a given change in temperature, it means the thermometer is sensitive. Range. A range, what are the lowest and the highest temperature that the thermometer can measure? So in range, if for example the common thermometers that we use in science labs start from -10 to 110 degrees Celsius. So the range is the difference from -10 to 110 degrees Celsius. So the difference, we call it the range. So here we have tried to simplify the definitions. Linearity of a thermometer is the property in a thermometer defined as the same distance between all degrees intervals. So this one is simplified now. Range is the difference between the maximum and the minimum temperature. Sensitivity is defined as the increase in length of the mercury column per unit increase in temperature. So this is in the case of a balloon. So I'm sorry, in a case of a liquid in bulb thermometer. So we're going to talk about the length of mercury, the length of the mercury per unit increase of temperature. That is sensitivity. Liquid thermometers. In a liquid in-glass thermometer, a liquid in-glass thermometer consists of a thin glass capillary tube containing liquid and that expand with temperature. We've said that at one end of the tube is a glass bulb containing a larger volume of the liquid which expand when heated, moving into the narrow tube. So this is the bulb. And then a scale along the side of the tube allows the temperature to be measured based on the length of the liquid within. So the sensitivity of liquid thermometers. The liquid used in glass thermometer are chosen for their thermal expansion properties. They expand linearly with temperature. We've said that. And two, they expand significantly, giving them a great sensitivity. So we cannot just use any liquid. There has to be a liquid which expands significantly, like mercury. Mercury is a metal and expand more because metals are good conductors of heat, so they expand significantly. And also sometimes you use alcohol. They have a low freezing point and high melting point and high boiling point, allowing them to be used over greater range of temperatures. So they have a low freezing point, so they cannot easily freeze, so that they can be used to measure a greater range of temperature, because when they freeze, they can the thermometric property changes, because now it would be a solid. So kumele ukuthi ibe liquid for, yeah, we able to use it when it is still a liquid. Sensitivity is another word for precision. Anything that makes it easier to detect small change in the temperature increases the precision or sensitivity of the liquid. Some of the factors which increase the sensitivity of the liquid, let us look at these four. It's using a thermometer with a smaller glass bulb. As a small bulb contains less liquid and therefore absorbs heat in a shorter time, so it makes it more sensitive. Use a thermometer with a smaller glass bulb. So that's number one. Another way to increase the sensitivity is using a narrow tube. We use a narrow tube. As a small change in volume result in the liquid moving a larger distance along the tube. So a small change, if the tube is wide, the distance moved by the liquid will therefore be small if the tube is wide. So that is why we use a narrower tube, because a narrower tube allows the distance to be moved by the liquid to be great. Number three is using a glass bulb with a thinner wall, as heat can be transferred to the bulb more easily and a small change in temperature can be more easily detected. Then lastly, using a liquid that expands more, e.g. mercury, which is a metal, so that increases the thermometer. A clinical thermometer usually contains mercury. Mercury is a metal and good conductor of heat, hence the thermometer is more sensitive. So it's more sensitive than that one of the laboratory thermometer. The constriction prevents the mercury from flowing backward before the temperature has been recorded. So please note that mercury is a toxic material, hence clinical thermometers should be handled with care, because clinical thermometers use this liquid, and dispose safely when broken. Users should wash their hands with running water. Swallowing or eye contact with the mercury should be avoided at all costs. They are not friendly. Now, let's look at the second example of a thermometer, which is the thermocouple thermometer. A thermocouple thermometer consists of two different types of wire attached together. Here we have an example. We have a copper wire, so you have copper wires, and then we have iron wires. So these wires are being attached together. they are joined using a small junction. So we call this a junction where they contact, and even this side. So we have a small, this side we call it a cold junction, and the other one is a hot junction. So it doesn't matter which one is a cold junction or which one is a hot junction. So there are two junctions in this example of a thermocouple. When one junction is at a higher temperature than the other, please note that one, an electric current flows, or a potential difference or a voltage is created between the two wires. So when this one is hot and this one is cold, so what happens? There will be an electric current flowing, the electric current generated, or there is potential difference generated, and then this can be detected here on the what, by the voltmeter. So it shows some reading. So this reading tells us that now there's some electric current that is starting to flow. The greater the temperature difference between the 2 points, the greater the potential difference. So if this one is very hot and this one is very cold, so the difference is great between the two. Therefore, the potential difference shown by the voltmeter is going to be great again. Advantages of a thermocouple is that thermocouples are not as sensitive as liquid in glass thermometer, but because the metals have high melting point, they can be used to measure a wide range of temperature, because the metals have a high melting point. So you can measure very high temperatures without the metals melting. Yet, when you are using a liquid, you'll find that at this temperature, the liquid has frozen, or at this temperature, it is no longer a liquid, it has started to boil, or even the glass can break in this case. They have a small junction and heat up quickly. Thermocouples are very responsive to rapid change in temperature because of the small junctions. A small change, a rapid change, like if it now it was, this time it is uh, 15 degrees Celsius, and then the next time it is 1000 degrees Celsius. So that's a rapid change. It can be detected easily by the thermocouple. While when we are using a liquid in pipe thermometer, the rapid change cannot be easily detected, because the expansion or the contraction of the liquid takes time while it is still moving up the capillary tube, or it's moving down the capillary tube. Long wires can be used. Thermocouples can be used in remote areas, e.g. furnaces or deep freezers. So you can use it in a remote area where you cannot access it physically. So you have the thermocouple left there, and it is connected to a computer, maybe in your office, when you want to monitor the temperature of a blast furnace, for example. So you don't have to be physically there to observe. So you can put the thermocouple in the furnace, and then you control it from the office, or you monitor it from the office. So this is another version of a thermocouple. So it still have the junction here, and then we still have the metal. So if metal one, maybe just say this one is iron and this one is copper, and they are connected to a voltmeter. All right, thank you very much.